11.7 is on geometric probability, and so in this section we're gonna find the areas of all kinds of geometric figures, and then we're gonna find the probability of those areas being hit. So we're gonna define sample space. Sample space is the number of outcomes in a random experiment. We need to know what sample space is. That's most of the time going to be our denominator in these kinds of problems. Probability is the measure of the likelihood that an event will occur. And probability is always going to be between 0 and 1. A probability of 0 is going to be some kind of an activity where it's not possible for that outcome to occur. If there's no chance, then it has a probability of 0. Something is the probability of 1, it's always going to happen 100% of the time. That's what a probability of 1 means. It will happen. So all probability is either going to be between can't ever happen or will happen every time. And that's what the 0 means. Never can happen, and the 1 means happens every time. This formula, P of E equals event space divided by sample space, that's the probability of an event occurring, is equal to the event space divided by the sample space. Sample space, of course, is everything. Geometric probability is going to have problems, give you problems like this. Assume that you're going to have a random point, K, on this line segment AB. What's the probability that K is on the smaller segment RS? Well, the probability of the point being on segment RS is going to be equal to the length of RS divided by the length of AB, because the event space is RS and the sample space is AB. So I don't really know what these lengths are here. We don't know any lengths, but this would be the answer for us. If we knew the length AB and we knew the length RS, then we could do the division to find what that geometric probability would be. I love the example of bullseyes. You know, so if you picture you're going to throw a dart at a bullseye, and you're going to throw it over your shoulder with your eyes closed. So it's not like if I was throwing the dart, because we know that if I was throwing the dart, hell, it would be 100% on the bullseye, right? Probability of hitting the bullseye would be 1, right? But let's just pretend that we're closing our eyes and we're tossing the dart over our shoulder, and it's going to hit somewhere on the dartboard. Well, what's the probability that it will be a bullseye? That will be the area of the bullseye divided by the area of the whole target. And that's this section.